All right, let's talk about one of the most important and maybe most misunderstood parts of building really great React apps, rendering efficiency. This isn't just some abstract, nerdy topic. Getting this right is the key to making your apps feel incredibly fast, smooth, and just a joy to use.
So let me ask you, have you ever built something in React where it just feels a little bit off? You type into a search box and the letters lag just a tiny bit. Or you click a filter and there's a noticeable pause before the UI updates. There are no errors in the console, but it just feels sluggish. Well, that feeling, that's the ghost of inefficiency we are going to hunt down today.
So, when you boil it all down, rendering efficiency is all about one thing: control. The goal isn't to stop rendering completely. Of course not. React has to render to show anything. The real goal is to stop all the unnecessary work. We want to be really deliberate about when a component re-renders, and more importantly, what else it takes along for the ride. And that brings us to our first big idea, this unseen performance drain. I call it unseen because a lot of the time the code looks totally fine. It works, it doesn't crash, but underneath the surface, it's just spinning its wheels, doing way more work than it needs to. And that's what creates that sluggishness we were talking about. The thing is, this problem almost always comes down to one of three main culprits. First, you've got components re-rendering when, visually, nothing is actually changed for them. Second, there's this sneaky thing called unstable references. We'll definitely unpack that one. And third, you have these giant monolithic components that try to do everything at once. So before you can fix a problem, you have to know what's causing it, right? So let's go through the fundamental reasons React even decides to re-render something. Think of this as your diagnostic checklist. If a component is re-rendering, I promise you it's because of one of these four things.
Okay, so the first three on this list, they kind of make sense. State changes, props change, context changes. Yeah, you'd expect a re-render. But that last one, its parent re-renders, this is the one that catches so many people out. By default, when a parent updates, it forces all of its children to re-render too, even if nothing about them has changed. That right there is the source of so many performance issues.
All right, now that we know the causes, let's get to the solutions. We're going to start with what I call the prevention playbook. These aren't complicated tricks. These are just good, solid habits to build into your daily workflow that will stop performance problems before they even start. First up, and this one is absolutely huge, keep your state as close as you possibly can to where it's being used. See, when you've got state way up at the top of your app, every tiny change can start a chain reaction, like a cascade of dominoes falling all the way down your component tree. And this shows it perfectly. On the left, you've got the simple search state being passed down through 6 different components. That means every single key you press in that search bar could be making dozens of other components re-render for no reason. The fix is so simple. Just move that state down into the component that actually needs it. You contain the blast radius of the updates. Okay, principle number 2 is all about how you design your components. Let's be honest, those huge do-everything components are a nightmare to optimize. They have too much state, they have too many responsibilities, and any tiny update forces the whole massive thing to re-render. The solution? Think small. I mean, look at this dashboard example. Before, it's all just one giant dashboard component. So if the data for the chart updates, guess what? The header, the stats, and the table all have to re-render too, even though they don't care about the chart data. But by splitting them into smaller, self-contained pieces, we can make sure that an update to the chart only re-renders the chart. It's so much smarter. Now, this next one is a little more subtle, but it is so important. Remember how a component re-renders if its props change? Well, here's the catch. In JavaScript, things like objects, arrays, and functions are compared by their reference, not their content. So if you create a brand new one on every render, React sees a new prop every single time, even if it looks identical. And here is the classic example. That inline style object on the left, it creates a completely new object every single time the parent renders. So from the child's component's point of view, it's getting a new prop on every render, which forces it to re-render, needlessly. The fix is easy. Just define that object once outside the component so it's a stable, static reference that never changes. Okay, we've covered the foundational habits. Now let's level up and talk about the power tools. This is memoization, and it is incredibly powerful for optimization. But just like any power tool, you gotta know when to use it, and maybe more importantly, when not to.
So what the heck is memoization anyway? Honestly, it's just a fancy word for caching. It's you telling React, hey, see this calculation or this component? Remember the result, and as long as the inputs I give you are the same as last time, just give me back the old result instead of doing all that work over again.
First step in our toolbox is React Memo. This is for your components. You wrap a component in Memo, and it's like putting up a shield. It will stop that component from re-rendering, even if its parent does, as long as its props haven't changed. Now, the key here is to use it on components that are actually expensive to render and that get stable props. Don't just wrap every tiny button in it, because there's a small cost and the overhead isn't worth it. Next, we have Use Memo, and it's really important not to confuse this with React.memo. Use Memo isn't for components, it's for values. Think about a really complex calculation, like filtering a giant list of data. You can wrap that calculation in Use Memo, and React will only rerun it when one of its dependencies, the values you've listed in that little array at the end, actually changes.
And last but not least, use callback. This hook's #1 job is to solve that unstable reference problem for functions. It memoizes the function itself, so you get the same stable reference on every render. This becomes absolutely critical when you're passing a function down to a child component that you've already wrapped in React.memo. If you don't use callback, you're just passing a new function every time, which totally defeats the point of using Memo in the first place.
Okay, theory is great, but let's see how all these pieces actually snap together. We're going to walk through a quick case study, taking a really simple but pretty inefficient component and give it a performance makeover using this new efficient mindset. So here's our before picture. You can see the parent is creating a new filtered array with that inline filter, and it's also creating a new onClick function on every single render. This means our poor child component is getting new props every time, forcing it to re-render again and again, even if nothing meaningful actually changed.
And here's the after. Look at that. It's beautiful. See how our tools solve each problem perfectly? We wrap the expensive filtering in Use Memo, so it only runs when the data actually changes. We wrap the onClick handler in Use Callback to give it a stable reference. And then we protect the child by wrapping it in React.memo. Now that child component will only re-render when it absolutely has to. That is efficiency in action.
So really, this all comes down to adopting an efficient mindset. It's less about memorizing APIs and more about a way of thinking, a way of seeing how change flows through your app. It's about striving for stable props, building small and focused components, keeping your state contained, and then using those power tools, memoization, surgically right where they'll have the biggest impact. And that's a wrap. But I want to leave you with one final question to think about. In the app you're working on right now, what's the one component, that big data grid, that complex form, that busy dashboard, that you could make just a little bit more efficient today? Thanks for tuning in.